Good day, everyone. Now we will discuss about our Module 3, the measurements of heat. Lesson 1, Heat Energy. Evaluation. Problem-solving making. I will make 5 problem-solving questions, then I will discuss it one by one and step by step. Now let's begin. Before we go to the formulas, we should learn first the stance of each acronym. Okay, first, where. Q stand for heat evolved. M stand for mass. C is stand for specific heat capacity. And triangle with a big T stands for change in temperature. So now let's proceed to the formulas. So we have here the equation of calorimetry is heat is equal to mass, specific heat, and change in temperature. Then we have here the initial temperature is change in temperature equals to heat evolved over mass and specific heat capacity. And the formula of mass is equal to heat evolved over specific heat capacity and change in temperature. Now, we already know the formulas. We'll proceed to the problem solving. So first, we should analyze what is asked in the problem, so we can easily know what is asked in the problem. Let's proceed to problem 1. A 3,500 joule of heat is added to 300 grams of copper, which has 390 joules per kilogram degrees Celsius. To each a final temperature of 120 degrees Celsius, what was the initial temperature of copper? So first, we're going to write the given. So what is the heat evolved? So we have 3,500 joules and the mass has 300 grams. So we have converted it and it is 0.3 kilograms. So the specific heat is 390 joules per kilogram degrees Celsius. And we have here the change in temperature. So first, we have seen in our problem, so the final temperature is 120 degrees Celsius. So the problem is we're going to find the initial temperature of the copper, which is this one. So we have here the solution. The change in temperature is equal to heat evolved over mass and specific heat. So now we have seen here the given, so we can just put it here. So the heat evolved is 3,500. So we're going to write here first. Then over the 0.3 kilogram, which is the mass. And the 390 joules per kilogram degrees Celsius, which is the specific heat. So we're going to times this one, the 0.3 kilograms times 390 joules per kilograms degrees Celsius. So first, we're going to cancel the kilograms, this one, and the joule. Then we will have here the 3,500 over 117 degrees Celsius. So after that, we will going to divide it. So 3,500 divide 117 degrees Celsius is equal to temperature of 29.91 degrees Celsius. So, we have our initial temperature of copper. Now, let's proceed to problem 2. It takes 130 joules to heat 15 grams of gold from 20 degrees Celsius to 80 degrees Celsius. What is the specific heat of gold? So first, we're going to write the given. So we have the heat 130 joules and the mass is 15 grams, and we have converted it into kilograms, and we have here the 0.015 kilograms. And the specific heat is equals to question mark. And we have here the change in temperature. So first, we have here the initial temperature of 20 degrees Celsius, and the final temperature is 80 degrees Celsius. So we will going to get the change in temperature by minus the final temperature minus the initial temperature. So 80 degrees Celsius minus 20 degrees Celsius is equal to 60 degrees Celsius. So we have the change in temperature is 60 degrees Celsius. So let's proceed to the solution. So we have here the formula. So the specific heat equals to heat evolved over mass times change in temperature. Second step is the specific heat is equal to 130 joules over 0.015 kilograms times 60 degrees Celsius. And the step 3 is we're going to copy the 130 joules and over the 0.09 kilograms, which is we have multiply it here by 0.015 kilograms times 60 degrees Celsius is equal to 0.9 kilogram degrees Celsius. So after that, we're going to divide the 130 joules, divide 0.9 kilograms degrees Celsius is equal to specific heat equals 144.4 joules per kilogram degrees Celsius. So we have here the answer of the specific heat of gold is 144.4 joules per kilogram degrees Celsius. Now let's proceed to problem 3. What mass of iron of 460 degrees joules per kilogram Celsius can be heated from 10 degrees Celsius to 150 degrees Celsius by 450,000 joules of energy? So first, we're going to write the given. So we have here the heat involved 450,000 joules, and the mass is question mark, and the specific heat is 460 joules per kilogram degrees Celsius. And we have here the change temperature. First is the initial temperature is 10 degrees Celsius and the final temperature is 150 degrees Celsius. So if we're going to find the change temperature, we're going to minus the final temperature and the initial temperature. So 150 degrees Celsius minus 10 degrees Celsius is equal to 140 degrees Celsius. So we have here the change in temperature. So now let's proceed to solution. So the formula of mass is equal to heat evolved over specific heat times change in temperature. So the second step is we're going to write the given. So we have the 450,000 joules over 460 joules per kilogram degrees Celsius times 140 degrees Celsius. So first, we're going to cancel out the joules, then the Celsius. So the remaining is the kilogram. So now let's proceed to the step 3. So the 460 degrees kilogram times 140 is equal to 64,400 kilograms. So the 450,000 joules is going to be 450 only. So next is we're going to divide the 450,000 divide 64,400 kilogram is equal to mass of 6.99 kilograms. So there. Now let's have the problem 4. At 25 grams of aluminum alloy will heat at 100 degrees Celsius with 910 joules of energy. What is the specific heat of aluminum? So first we're going to write the given. We have here the heat evolved of 910 joules and the mass is 25 grams and we converted it into kilograms and we have here is 0.025 kilograms and the specific heat is question mark and the change of temperature is 100 degrees Celsius. Now, let's proceed to solution. We have here the formula of getting the specific heat of aluminum, which is specific heat is equal to heat evolved over mass times change in temperature. Next is we're going to put on the given. So we have here the 910 joules over 0.025 kilograms times 100 degrees Celsius. So first we're going to multiply the 0.025 kilograms times 100 degrees Celsius and we have here is 2.5 kilogram degrees Celsius. And we will just going to copy the 910 joules over here. So then we're going to divide the 910 joules over 2.5 kilogram degrees Celsius. And we have here the answer. We have here getting the specific heat of aluminum is 364 joules per kilogram degrees Celsius. Our last problem is John places 25 grams in ice in a glass with 840 joules per kilogram degrees Celsius that can heat in a fusion of water of 28 degrees Celsius. How much energy would be absorbed by during the melting process? So first we're going to write the given. So the heat evolved is question mark. The mass is 52 grams and we converted it into kilograms. And we have here the 0.052 kilograms. So the specific heat is 840 joules per kilogram degrees Celsius. And the change of temperature is 28 degrees Celsius. So the formula of getting the heat is equal to mass times specific heat times change in temperature. So first we're going to write the given. So the given is 0.052 kilograms times 840 joules per kilogram degrees Celsius and times 28 degrees Celsius. So first we're going to cancel out the kilograms, no, and then the Celsius. So the remaining only is the joule. So as we multiply it, we have here the answer is the heat is 1223.04 joules.